In this video, we're going to look at setting up a Arduino ultrasonic distance measuring tool. We're using the ultrasonic sensor here, the HCSR04 sensor. We're using the Arduino Mega 2560 board. We have a breadboard here. We have a LED here, a red LED. We have a 220 ohm resistor. And we have some wires, and we have our USB connected to our computer to power the device and also upload the code to the board. So let's take a look at how we've wired this up and how we've set it up. So we have a positive 5 volts terminal on the board connected with this orange wire to the positive rail on our breadboard. We also have the ground terminal on a board with this purple wire connected to the negative rail on our breadboard. From that, we have connected the ultrasonic sensor. We have a ground, 4 wires connecting the sensor. So we have a ground, an echo, a trigger, and a positive or VCC connection. So the red wire is the positive 5 volts, which is the red wire here, going down into the breadboard, through the breadboard into this orange or brown wire, onto our positive rail here, which picks up our 5 volts here. We have our negative or ground wire, black one here, goes through the breadboard, goes through the white wire, picks up the negative rail here, which picks up our ground wire here connected to the board. We also have the trigger connection, which is the yellow wire. So the yellow goes to pin 9 on our board. The green is our echo wire or echo terminal. It goes to pin 10 on our board. So that's the wiring of the ultrasonic sensor. We also have a red LED light here. So if we go to 5 centimeters, we get the flash. Above 5 centimeters, we won't get the flash. So this LED is hooked up via pin 7, being the positive side. Goes through the board, through the 220 ohm resistor to the positive side of the LED. Through the LED to the negative side, through the board, back through this black wire into the negative side of the rail on the breadboard. Then back into the ground on the board. So here is the code that we're using for our ultrasonic distance measuring tool using the Arduino sensor. We've saved the file. We've set up the environment. So we've set the board to the Mega 2560. We've also set the communication port here to COM4. In this case, we run the check on the code. We check that it's done compiling. Then we upload the code after we connect the USB to the Arduino board. So we upload there with that button there. And you can see here it's uploading. Then we start getting the distance measured. I've set the sensor to be approximately 5 centimeters from the object. We have some comments here for the start of the program, multi-line comments. We have some constants here, integer data type and a float. We've set trig pin variable to be 9, echo pin to be 10, and LED pin to be 7. They're constant because we're not updating these values inside the program. We have a float data type for our decimal number. We've assigned it 5 for alarm distance variable. We also have 2 variables that we're going to update in the program, so we haven't defined a value here. Long data type for duration. Long data type allows us to store longer or larger numbers. And a float data type for distance allows the decimals to be stored, decimal numbers. We have 2 main functions, the setup function and the loop function. The setup function always runs once and the loop function runs repeatedly. We've set the baud rate at 9600, so the baud rate is the speed at which the data is transmitted between devices. So 9600 is 9600 bits per second. Pin 9 will send signal out. So we've set it as an output. Pin 10, which is echo pin, will be an input. We've set that one as an input to receive signals. Pin 7, which is LED pin, which we've set, is set as an output to make the LED light glow. Coming down to the loop function, we're setting up our ultrasonic sensor here. Pin 9, which is trig pin, we've set up the top here. We've set that to low, which means we've set it to 0 volts. Then we wait 2 microseconds. Then we send a trigger pulse to trig pin, or pin 9. We send a 5 volts, a high. So we send 5 volts down that line. And we hold it at high for 10 microseconds. So the ultrasonic sensor, or the HC SR04, requires a 10 microsecond trigger pulse. So we delay for 10 microseconds. Then we set the voltage on that same pin, trig pin, or pin 9, to low, to 0 volts. We turn it off. The sensor now sends out ultrasonic sound, and we now read the echo time. So this is where we store that value or number in the duration variable. So we wait for the echo to go high on the echo pin, which is pin number 10. Wait for it to go echo to go high, so 5 volts. Then we measure how long it stays high for in microseconds. So the microseconds to travel out to the object and back to the ultrasonic sensor. So we're measuring both ways. So we need to do some math to compute that, to process that measurement. And this is where we do it. So the speed of sound is approximately 0.0343 centimeters per microsecond. And we're going to use the formula, the distance equals the velocity times the time. So the ultrasonic sensor sends out that sound wave, which is traveling at this speed. So that's the velocity. And we know the time, we've measured that. So we've got the velocity times the time that we've measured up here. But then we're dividing it by 2. And the reason is because the duration is the sound going out, then back from the object. So we're measuring both ways. We only want to measure the distance to the object, so we need to halve it. So that's why we're dividing by 2. Then we just print the results to the serial monitor, which we can see down the bottom here. We've got the sensor set at about 5 centimeters from the object. So it's recording 5 centimeters approximately. So we print some text, then we print the actual number from here. Then we print the units, centimeters, on the end of that. So this is where we get each line here. from this part. Then we do some checks on that distance to either turn the LED on or turn it off. So if the distance, this number here, is less than or equal to alarm distance, which we've set up here at 5, we'll turn the LED pin, which is pin 7, we've set that as a constant up the top. We'll set that to high or 5 volts, so that'll turn the LED on. Then we'll delay 200 milliseconds and we'll set it to low. So that'll turn the voltage off, or pin 7 to 0 volts. Then we'll delay 200 milliseconds. So this is what creates that blinking effect of that LED when we're at 5 centimeters or less. But if this is not the case, if this part is not true, we'll then execute this part here, else. So we'll set the LED pin to low or 0 volts, so the LED stays off. We'll delay 100 milliseconds before taking another measurement, going up to the top of the loop